Aloha and welcome. In this video, we're going to be talking about WLAN authentication and attacks. So we've talked about WLAN authentication when we were talking about authentication. We've got 5 primary authentication options for wireless local area networks. One is going to be pre-shared keys, PSKs. That's where you've got a shared credential that's used for device authentication. You've got EAP, the Extensible Authentication Protocol. Remember, that's an authentication framework for transporting different types of authentication protocols. We've also got IEEE 802.1x, which is an IEEE standard for port-based access control. We've got Radius, which is the remote authentication dial-in user service, and that's a networking protocol for centralized authentication, authorization, and accounting, which is AAA, the AAA services. And then also another AAA, we've got the Terminal Access Controller Access Control System Plus, the TACACS Plus. That's a proprietary networking protocol by Cisco, and that also gives you authentication, authorization, accounting, and auditing. So the next thing we're going to talk about is spoofing. So one of the things to worry about in wireless networks is spoofing. And spoofing, we've been talking about MAC address spoofing, and that has a role. But in this context, we're talking about spoofing as in devices that are trying to get trying to get into the pathway. And one of the things is a rogue AP. So a rogue AP being access point. A rogue access point is an access point, and it could be non-malicious or it could be malicious that exists. So for example, somebody in your office may have set up an extra wireless router or maybe a wireless extender or something like that. But it's what we call shadow IT. It's not being managed by your IT department. So it's a rogue AP. It doesn't have a malicious intent. It's meant to better things, but it's a rogue AP. When rogue AP turns into something more malicious, we call it an evil twin attack. And that's when you put it's when you put a rogue AP in an environment with the intention of somebody else connecting to it. So you're using the same SSID. So if I had, let's say I had a access point named with an SSID, John's, call it John AP. So John AP, let's say somebody wanted to put in an evil twin. What they would do is they would create another one. They would bring in another AP in the environment, name it the same thing, give it the same SSID, and then maybe even boost the power on it. Because APs work, when you associate with an AP, you usually use the one that's got the most power, the one that's theoretically closest to you. So what sometimes these evil twin attacks do is they'll amp up the power that they have so that you'll associate with them rather the AP that you were previously associating with. And then once they've done that, now they're on path. They're man in the middle in this sense. There's a way to prevent this. It's called a wireless intrusion prevention system, a WIPS, and that can monitor the WLAN and detect and prevent these intrusions. So if it detects it, it can quarantine it and it can prevent others from associating with that evil twin. So that's good. So we were talking about on-path attacks, and that's the type of attack when an attacker eavesdrops or modifies the communications between two different parties. So in an on-path attack, both the parties are going to be unknowingly communicating with that attacker, so they become that man in the middle. And once they've done that and they've gotten in between, they can do things like DNS poisoning attack. And that's the DNS poisoning is the attack where they can redirect users to malicious websites by modifying the user's DNS query. So when the user goes out there to do DNS resolution for something, if you've got that man in the middle, the on-path attack, they can give you back a record. Because what's going to happen is the device is going to go out and look at the resource here, but because it's going through this evil interloper, that interloper, the attacker can modify those DNS requests as they come through. The way to get around to protect yourself from this, the way you mitigate this threat is through using a secure channel. So if you use a secure channel, your communications are going to be encrypted, and it's going to have data confidentiality and authenticity guarantees. So that's the way you mitigate these risks. And then the last thing is the deauthentication attacks. Deauthentication's attack is when you're trying to prevent an association with a WLAN. So authentication, it's the act of verifying or proving a user's claim to an identity. We talked about that all the way back in the beginning. Well, authentication may require a user to provide a shared password or unique login credential. So an authenticated user is fully associated with the LAN, can access the protected network resources. So an attacker is going to de-authenticate a WLAN user to hijack the user's authenticated session, or maybe even just to deny service to the WLAN. So de-authentication is an attack where a user's authentication is invalidated. So along with that is jamming. And jamming is an attack where you use a high power loud signal to drown out the legitimate communication that's going back and forth between an end user and, let's say, the routers or the wireless access point. So what you do is you perform a denial of service just by putting a very loud signal out there that's going to jam it up. So and you can use that as a kind of a segue into doing something like an attack on a WPA TKIP password scheme. So anyhow, that's that for this section. So remember that we have 5 different types of authentication on WLAN. We've got PSK, EAP, we've got IEEE 802.1x, we've got Radius, TACACS Plus, we've got spoofing, we've got rogue APs, evil twins, we've got the wireless intrusion prevention systems to prevent those evil twins and rogue access points. We talked about the on-path attacks, trying to get in between the two, and you can do DNS poisoning attacks that way because you can actually see that communication that goes in between. How do you prevent against this? By using secure channels. So using secure channels, you're going to be encrypting, and that's going to prevent it's going to prevent you from getting the DNS poisoning. So deauthentication attacks we also talked about, and that's when you try to invalidate the user's authentication, and you can use something called jamming to try to drown out their signals. So that's it for the section. If you have any questions, feel free to reach out. Aloha.